In review packet number 1, I'm going to go through a few more questions starting with number 6. Looking at your responses, a lot of you have the right idea. It's just see how it says simplify? That means you've got to give me the tiniest answer possible. Some of you have equivalent answers, but not the simplest answers. So that's what I want to talk about today. We're going to go through a few of these, like I said. You should also remember last time we were working with finals for the final exam. You guys should have this list. It's going to keep growing. But I want to start off with this page today where it says formulas to know. And I gave you guys the double angle formulas and the sum difference formulas. Well, if you notice, part A, 6A, says sine 2x all over sine x. Well, sine 2x can be changed into 2 sine x cos x. And then we keep the denominator, which is sine x. And I'm hoping now that you guys are looking at this and realizing the sine x's can simplify off or cancel. And so the answer to A is 2 cos x. And a lot of you did have that as an answer, which was great. All right, now the next one. It says cos 2x all over sine x. Now, a lot of you gave me equivalent answers, but not necessarily the simplest. So the denominator is sine x. I'm going to start with that. Now, we have 3 different choices for cos 2x, right? These are the 3 different options. Considering the denominator had a sign in it, I'm going to go with the one that has sine in it, 1 minus 2 sine squared. So I'm going to put 1 minus 2 sine squared x. Now what I'd love to do is cancel this, but I can't at the moment. I actually have to split this into 2 fractions. So anytime you have a single denominator with multiple things on top, it is completely legal and usually very appropriate to separate it into 1 over sine x minus 2 sine squared x over sine x. Now, some of you on your answers left this as 1 over sine x, but 1 over sine x can actually be simplified to be cosecant x, so that was required for you to do. And then here, this sign will cancel with one of those, which would give me minus 2 sine x. So this is actually the best answer for 6B. And again, a lot of you are close, you just didn't clean this part up. Now, 6C I'm not going to fit on here, so I'm going to pull out a piece of paper. All right, 6C, I'm going to rewrite it a little bigger, is sine x over cos x plus cos x over sine x all over 1 over sine x. All right, so when I look at this, I'm like, all right, we're adding fractions. For adding fractions, what do we need? I'm hoping you're thinking common denominator. So what I'm going to do here is multiply this guy by sine x. Whatever I do with the denominator, I have to do with the numerator. And this one I'm going to multiply by cos x. All right. So now I have, this becomes sine squared x over sine x cos x plus cos squared x all over sine x cos x all over 1 over sine x. All right, now since I have a common denominator here, I can combine those. Now, what is sine squared plus cos squared? What is that, everybody? Hope you're screaming 1. That's our first Pythagorean identity, which we're going to add to our formula sheets in 2 seconds. So sine squared plus cos squared makes 1. I keep the denominator all over the denominator, 1 over sine x. And at this point, I can just do keep, change, flip, right? I'm going to multiply by the reciprocal. Okay. Sine x cancels with sine x. I get 1 over cos x. Now again, some of you did leave that as the answer, but it's not in the simplest form. This would actually be secant x. And that's the answer to 6C. Okay, now with that, I want to add to our formula sheets here the Pythagorean identities. Okay, and the first one is the one we just used, sine squared plus cos squared equals 1. And there are 2 more that can be made from this. I don't know if you guys remember, but if I divided all 3 of these by cos squared, sine squared over cos squared makes tan squared. Cos squared divided by cos squared is 1. And 1 over cos squared makes secant squared. And then I could divide it through by sine squared, and you end up with cotangent squared plus 1 equals cosecant squared. So these 3 are super important as well. Okay. So that was it for number 6. Now, number 7 was actually really good. A lot of you got it. A lot of you got it, but didn't give me the answer in simplest form, which we do have to work on. Log 2x minus log x minus 3 equals 1. So I'm going to, in the land of the logs, I'm going to rewrite that as subtraction becomes subtraction equals division in logs, right? So this is going to become log 2x over x minus 3 equals 1. So anytime you have 2 logs subtracting, as long as they have the same base, and what would the base be for these if there's nothing there? Good, 10. You can change subtraction to division, and addition would become multiplication. Now it's time to do Ben. B-E-N, good old Ben. What is my base? 10. All right, the baby number is the base. My exponent, logs equal exponents, so my exponent is 1, and it would equal the fraction. Right? So what I'm going to do now, since this is a fraction, I'm going to make that look like a fraction and cross multiply. So I end up with 10x, right, so I'm bringing this here, 10x minus 30 is equal to 2x. I'm going to subtract the 10x over, so I end up with negative 8x, and I'm going to divide by negative 8. So a negative divided by negative makes positive 30 over 8. Now some of you had that down as an answer. I didn't accept it. Technically it is equivalent, but guys, come on, this can be reduced, right? Divide both of these by 2. You get 15 over 4. So that would be the best answer. Some of you also gave me 3.75, which I took as well. But fractions are always perfect. All right, now number 8. We have not done one of these in forever. It's been like since November or end of October. This is our first trig equation. It says solve 2 cos squared x minus 1 equals 0 over the interval 0 to 2 pi, right? Remember, 2 pi is 360 degrees. All right, so 2 cos squared, right? So I'm going to write this a little bit bigger. So 2 cos squared x minus 1 equals 0. Now there's 2 ways, actually 3 ways of doing it. You could use, you could factor it. You could try using the quadratic formula. Actually it doesn't factor, so you have to use the quadratic formula. Or, quicker way, going to add over the 1. Right? Divide by 2. Okay. Now, see how it's cos squared? So I'm going to take the square root of both sides. All right, so I end up with cosine x equals. Now, when you're taking the square root of something, it's plus minus. What's the square root of 1? 1. Can we take the square root of 2? No. All right, now, this is really important because if I fix this, I rationalize the denominator, I end up with plus minus radical 2 over 2. All right, you guys. Radical 2 over 2. What special angle always goes with radical 2 over 2? And I hope you're thinking 45 degrees, right? Now the plus minus is important. And everywhere cosine is negative. So that means I'm going to draw 45 degrees against the x-axis in all 4 quadrants. And I need to come up with all of those angles. So from here to here is 45 degrees. So right now if x equals 45, from the x-axis to this line would be 135. From here to here is 225. And from here to here is 315. Now, this is where we have to look at our interval. Notice it's written in pies, which means we cannot leave our answers in degrees. Okay. 45 degrees. Do you guys remember what that is? All right, I had put that on our little formula sheet here. Pi over 4 is 45 degrees. So that means 45 degrees is pi over 4. Now, 45 times what number would make 135? So if you take a second, it's going to be 3. So that means I'm going to have 3 pi over 4. 45 times what number makes 225? That would be 5, so that would be 5 pi over 4. And then how many 45s do you need for 315? You need 7 of them. So 7 pi over 4. So these are the answers for number 8. All right, now, number 9. Just like before, we're not going to have enough room, so I'm going to actually rewrite number 9 on this paper here. Number 9 says we have cos 2x plus 3 cos x plus 2 equals 0. All right, and we want to solve this from 0 to 2 pi, but notice it's a soft bracket, so that means if 360 comes up as an answer, we can't use it. All right, now, this has a special issue. This one's special because of this. We have a double angle formula. You cannot do a trig equation with a double angle formula in it. You have to substitute it in with one of the 3 options. Right? So we have 3 options. Look what's here. This is a cosine. So the smartest option to use is the option with just cosine in it. So what I'm going to do is replace cos 2x with 2 cos squared x minus 1. So I replace him with him, and then I'm going to bring the rest of this down. Okay, now I'm going to put this in the correct order. So it's 2 cos squared x plus 3 cos x, and combine like terms, right? Negative 1 and that plus 1. Okay. Now, this can be factored. Now again, I wrote this whole test so it could be done without a calculator. You guys are obviously at home. I am not there, so you obviously have your calculators available to you along with all the formula sheets. Thing is, don't go too slow. You're only going to get 3 hours to do the whole thing, which is way more than enough time. But I'm going to be really strict about it's got to be in within the 3 hours because I'm giving you guys all these, you have all these things available to you. But this is going to factor into 2 cos x plus 1 plus 1. So you could use the quadratic formula function on your graphing calculator. So I'm going to factor it. Then set each piece equal to 0. Now I am going to be looking at the work, so I am going to expect work for all this. Okay. So this will end up being cos x equals negative 1/2. This will be cos x equals negative 1. Now, I like to do the whole numbers first. Whole numbers, 1, 0, or negative 1, means the answer comes off the unit circle. Where on the unit circle is cosine equal to negative 1? And that would be right here, right? That's the point negative 1, 0. And that happens at 180. Now, 1/2. What angle makes cosine equal to 1/2? Now, you guys are going to have your calculators available to you. So this is where you go to your calculator I put cos to the -1, plug in a half. Do not put the negative in, just the positive. When is cosine going to be equal, cos to -1/2? Right? You should be getting 60 degrees pop up. Now that is not the answer. That's the reference angle. Okay. What you need to do now is place the 60 degrees in the quadrants where cosine is negative. Right? So it's A, S, T, C. A means all are positive, so I'm not putting it there. C, cosine's positive, so I'm not putting it there. So that means I'm going to draw 60 degrees here and here. So from here to here is 120 degrees. So x equals 120. And from here to here is 180 plus 60, so that is 240 degrees. So 60 was our reference angle. The negative told me what quadrants to put it in. And now, these three would be the answer. However, if you look back at the interval, it is written in pi form. Oops, see there? Pi form. So we have to convert these. 180 degrees, right? 180 degrees is pi. So that's that guy. That's important. Now, reference angle 60. Pi over 3 is 60 degrees. How many 60s do we need for 120? 2 of them. So that would be 2 pi over 3. And how many 60s do we need for 240? And that would be 4 pi over 3. So those are the answers. All right, so I'm going to pause there, and I'll shoot another video for the next portion.